it's not recording, like you know how it says on air? If you notice it bumps off, let me know, okay? Okay, so double roots means multiplicity of 2. All right, so I look here. Is this in factored form, Joanna? It's been grouped, right? As long as you have brackets around the x's, it looks grouped. So this is a very strange looking one. So are there any, here I have 2 terms. Even though the terms have exponents on them, I only have 2 terms because terms are separated with a plus sign, right? So is there a common factor here? What's the common factor? X plus 1, right? So I'm going to pull out an x plus 1. Oh, x plus 1 squared, I guess. That's the most they have in common, right? And I'm going to use square brackets now for what's left over, just to differentiate. Okay, if I factor out an x plus 1 all squared from this term, I'll be left with an x plus 1. Agreed? Then this one, this divided out of here, factored out of here, is going to be a plus 1. Okay? So now what do I have? I guess I could say this would simplify a bit too. X plus 1 all squared. And then this would be x plus 1 plus 1. I guess this would be x plus 2. All right, so in the end, what kind of polynomial? This looks like it's a cubic, right? And of course it is. That would be the highest power. So what are my x-intercepts? Say each bracket equal to 0, right? Like -1 and -2. Are there any double roots? Yeah, here, right? This is multiplicity of 2. So just pushing this a little further, getting you more prepared for the test on Monday, what if I asked you to make a real quick sketch of this? Could you do it? Let's see. I'm just going to move this up a little bit. What do we have here? Whoa, I'm not even going to do a proper, I'm just going to do a really, okay, sorry, I'll just record this again. So what do we have? We have f of x equals x plus 1 all squared times x plus 2. We identified that we have x-intercept of -1, x-intercept of -2. This is multiplicity of 2, right? Okay, what's my, can you guys do this in your head? What's the y-intercept? 2, right? If I put a 0 here, that's just 1. 0 here, that's 2, so 2. Okay, this is really bad, a really bad graph, because I'm not even using a ruler. So don't ever do this. Don't do what I'm doing. Okay, y-intercept, x-intercept, and -2, right? 1 tick equals 1. Okay. What happens at a multiplicity of 2? Bounce, right? What happens at a multiplicity of 1? Crosses, right? Crosses cleanly. All right, and this is a cubic, right? A positive cubic or negative cubic? So I know the shape is kind of like this, so it ends over here. So I guess it goes like this somehow, right? Whoops, shouldn't curve either. I don't know. And then it bounces here, right? I'm going to put B for bounce. Bounce, cross. There. That's kind of what the graph looks like, right? Good. That was a tricky one, Joanna. It was sort of kind of hiding there, right? All right. Anything else? No? Okay, I had told you to omit 19, 20, and 15. We're actually going to use the Chromebooks a little later, and we're going to do some solving. We'll see how technology could help us solve the big ones. But let's take a look first. We'll do that a little in a few minutes. Let's look at those last 2 examples. I know you were asking me about them before, Chris, yesterday, about will we do those last 2 examples in the pink booklet. And we are going to. We're going to finish up this booklet today. again, it's modeling and solving problems. So you're going to be introduced to a couple. I have another couple of examples. Then I have a worksheet for you to just look at and work on, as well as we'll get some exposure with the Chromebooks. So problems involving polynomial functions. So another word for problems is, you'll see sometimes in math textbooks, or I'll refer to it as applications, because you're applying your knowledge, right? So just the word applications means word problems. And again, that's why we study math and science. So the only thing, the word of warning I'm going to give you about application problems is, it's when you just study the pure math of it, like the equations that we were doing when I was telling you, giving you polynomial, the one we just looked at, and I said just graph it. You're supposed to graph everything, right? And you work with the whole function. But when we look at real life problems, real world problems, we're actually solving a real world problem, and that constricts things, if you know what I mean. In a real world problem, you typically don't use a lot of negative numbers, right? So we have to restrict our domain, and I'll talk to you a bit more about that. But what I'm saying is, sometimes you'll get like perhaps 3 answers for x, 3 x-intercepts. But in the problem you were given to solve, not all of the x-intercepts will make sense, right? If I'm solving a problem about how much drug to prescribe a person, and if I get answers of like x equals -3, x equals -2, and x equals 5, I can't prescribe a negative amount of drug, right? Or I can't walk a negative amount of kilometers. Do you see what I mean? That's the trickier part of applications, because you have to think, what is the story of this problem? If negative numbers don't fit into the story, you have to discard them, right? Okay, so let's just see. The volume, and another thing, in these word problems, you'll see in the polynomial section, a lot of the application questions tend to involve volume. Because what is volume? It's a cubic measure. Does anyone remember the formula to find the volume of something? Well, yeah, liquids can be measured in volume. But what's the formula for volume? Length times width times height, right? These are ones you should know from previous classes. Area is just length times width, right? Area is 2-dimensional. Now, you might have an area question in polynomials, because what happens is, for example, just to do a bit of a refresh, area is 2-dimensional. Like I talk about area, 2-dimensional things are flat. Like this board is flat, the floor is flat, the wall is flat, the tabletop is flat. You'll typically see area questions when you're doing something with floors or carpets or painting walls, because you have to know the length of something and the width of something. So let's say my length is 20 meters and my width is 10 meters. Then I say that the area is 20 times 10 is 200 meters squared, right? Volume, if my length is 20, my width is 10, and my height is 5, the volume of something would be 1,000, right? 1,000 meters cubed, right? Because I'm taking 3 dimensions. So you can see why area and volume might turn up in applications part of polynomials, because we end up with cube terms and square terms. So that makes sense that this first question talks about volume. We're doing a problem with volume because it's a cubic measure. Okay, so it says the volume in cubic centimeters of a rectangular box can be modeled by the polynomial function volume equals 3x cubed plus x squared minus 12x minus 4. Determine expressions for the other dimensions of the box if the height is x plus 2. Okay, we're not really solving anything here. And it says determine expressions. So those are just the factors. Determine the factors for the other dimensions of the box if the height is x plus 2. Okay. So what would the other expressions, what would the other factors be? How am I going to find, like, the volume equals this whole thing, I guess, when it's multiplied out. So I know it's x plus 2. Now I'm looking for the other two factors. This might be the length or width or height, I'm not sure, but I need two other factors. One for length, one for width. How am I going to figure that out?
X.
Yeah. A is negative 2, right? Divide the polynomial by x plus 2. Okay, so we're not actually officially solving anything, but let's just see what we get. So I have negative 2 into this 3, 1, negative 12, negative 4. Drop my 3 down. Okay, so here I go. I have 3x squared minus 5x minus 2 times x plus 2, and that's the volume of this thing. 3x plus 1, x minus 2. Yeah. So that's it. I can't go any further. There might be, I don't know if I have a question on the sheet, but I could actually solve for x and then figure out what length, width, and height are if I gave you a volume, though. I'd have to give you what the box was. If I gave you the volume of the box, then I could get you to solve for these. But they just said determine expressions for the other dimensions. So these are these three factors represent the three dimensions of the box. The length, the width, the height. Now, I don't know which is which. Without knowing what x is, I don't know which is which. So I just have to leave it like that. Okay. Maybe what we could do. All right, so now let's try this type of question. 3 consecutive odd integers have a product of negative 105. What are the 3 integers? Okay, let's talk about this one. What does the word consecutive mean? Following, right? Yeah. Consecutive means one after the other. So 1, 2, 3, 4 consecutive numbers, but it also says odd. So what are the odd numbers? Examples of odd numbers. 1, 3, 5, 7, ... Okay. So they're not divisible by 2. We know that. Okay, this is the issue. I don't know any of the numbers yet, but I know they follow each other in an odd pattern, right? And I know the product. And what does product mean?
The result, I think.
Multiplication, right? The product is the answer in a multiplication question. So I have to start somewhere. I would say let my first number be x. Okay. Now, in math, if you only have one statement, like here I only had a volume statement, right? If I only have one statement, I can only solve one statement questions if they have one variable in them, right? So it doesn't help me at all to say, let me call my first number x, my second number y, and my last number z, my 3 numbers. You won't be able to solve a math problem if you call all your numbers different variables, right? You can only solve a math problem if you call them all something in terms of x, right? So if my first number is x, my second number,
X plus.
yeah, must be, Well, the consecutive, let's just pretend my first number is x. My second number would be 3, right? My next consecutive. So I'd have to say x plus 2, right? All right, then my third number, gentlemen, what's my third number going to be called? Perfect, right? Because from here to here is 4, the distance of 4, right? All right, this means that x times x plus 2 times x plus 4, this number times this number times this number has to equal negative 105. Do you think we could do this one with pen and paper? Negative 105 isn't that big of a number, but how would you do this question with pen and paper? How would you proceed with this question without a calculator? Yeah, you could figure out the factors of 105, right? Just break it down. There's probably not that many and do it trial and error. Could you do it using a process we learned in class at all? Could you do it with long division or synthetic? What would you do? No? You want to just guess and check? Okay. We could do this graphically easy, right? Using technology, we could use it fairly easily. I mean, you could do it. I probably, if I was stuck in just knowing what I know now, this is probably how I would do it. I would multiply everything through and get a proper cubic, right? So I'd probably go. We're going to come back to this one, and we're going to do it using graphing technology when we start that too. Just so you can see how nice technology makes our lives, right? And then I guess I'd move my 105 over, right? Mm-hmm. Then I'm going to get x cubed plus 6x squared plus 8x plus 105 equals 0. Right? Now, if I could just find a good a value and I could start dividing, I'd probably find some answers for x, right? It says 3 consecutive odd numbers. All right, so I don't know. Factors of 105. What numbers go into 105? One, 3 plus or minus, right? 1, 3, 5, 7, 15. Let's hope that it's not past these guys, right? It's definitely not 1. I can see it's not 1. It can't be positive 1. I don't think it's negative 1 either. This would be p at negative 1. That doesn't work. I said no calculator, but I guess we can use it. We'll use a calculator a little bit for. So what do I have? 27. Yeah. Can everyone see that it absolutely can't be a positive number? You can see that. So you're only going to be trying the negative numbers, right? Okay. So let's do negative 3. So I have negative 27 plus 54 minus 24 plus 105. That's not big enough either, right? Okay. Is it negative 5? No? It is? No. Oh. Minus 40 plus 105. Are we getting closer though? Maybe? I don't know. Negative 125 plus? Negative 7. Yay! I thought it was from remembering, yeah. Are you sure it's not the negative 5? 6 times 25 is 150. Negative 125 plus 150. I think negative 7 works too. This works, doesn't it? Okay. So -7 or -5 works. That kind of makes sense to me. So I'm thinking my x is x equals, or x plus 5 is a factor. So if x plus 5 is a factor, this means x equals -5. Agreed? And if x equals -5, let's go back here to my opening statements. Look what I had here. If my first number is -5, if x equals -5, okay, what will my second number be? -5 plus 2 equals -3. And -5 plus 4 equals -1. That doesn't make sense though. Hang on. It doesn't work? Sorry, I thought it did. -125 plus 150 minus 40 plus 105. Oh, you're right. I should have listened to you, Evie. Okay. P at -7 works, right? That's better. X equals -7 then. X plus 7 is a factor. X equals -7, right? Sorry about that. Because 5 times 3 times 1 doesn't give us 105, right? So x equals -7. X plus 2 equals -5. X plus 4 equals -3. So those are my 3 integers, right? The 3 integers are the 3 consecutive odd numbers are -5, -7, -3. Okay, are those consecutive odd numbers? Yep. Do they multiply out to give me -105? I think so. -7 times -5 times -3. And there we got our -105. Okay? Probably your way of doing it, trial and error, Johannes, would have been a lot quicker. But they're not always going to be this, the numbers won't be that small. Okay, so that's kind of a silly question in a way, because really, I guess you could say, who cares? Who cares about that question, right? It's not a typical polynomial question though. I got a couple things to hand out to you today, so sorry about all the extra paper, but we're going to take a look at a couple of other applications that might make things a little more valuable to you, right? There's 2 sides. We're going to talk about polynomials and graph. Then we're going to revisit some of those weird questions in the textbook that ask for terminology. So when you look at the first graph we give you, I want you to look at 2 things. I want you to look first, it says applications of polynomial functions. The first thing it gives us is an equation, right? In f of x form, except we're using h and t. And usually we use descriptive variables. So we'll see why h and t was used. A parachutist jumps from a plane 11,500 feet above the ground. The height h in feet of the parachutist above ground t seconds after the jump can be modeled by the function h of t equals 11,500 minus 16t squared. Is that a polynomial function? Yeah. It's got a constant, it's got a coefficient, and it's got variables squared. The squared is a whole number, non-negative, so perfect. What type of function is that? It's quadratic, right? What is it, a positive or a negative quadratic? Negative, right? Now, usually written in proper order, it would be what? Yeah, we'd write the minus 16t squared, right? The only reason it's written like that is some textbooks, and therefore some worksheets we give you, don't like to start a math sentence with a negative, so they started with the positive number. But it's a polynomial. You can tell it's a negative quadratic, right? What does a negative quadratic look like? This, correct? So if this was a previous lesson that we had done, this is what, or if I asked you to graph this, you would graph this, correct? But now we're doing word problems, applicable word problems. Can you see why the graph, like this graph has been cut off, right?
Is it cut off at the x-symmetry?
Not necessarily. That's a good question. I don't, probably not. It was probably cut off more like this, Eduardo, like that, right? It doesn't necessarily have to be cut off by the axis of symmetry. Whoops, it's just going to be cut off where numbers are positive. So only the positive part of the graph is shown. Because what are we talking about? What are we tracking here? We're tracking someone's height over time. Time can't be negative, and the height can't be negative, right? We're hoping. What would if the height was actually negative? What would happen? The parachutist would have hit the ground without the parachute probably and dug into the ground. So this is a realistic, right? We don't want that. So height can't be negative. The lowest the parachuter is going to go is 0 meters or 0 feet. Now that's going to be part of your job if you ever have to graph a realistic explanation or a realistic context problem or understand one. This is a big deal in the applied math class. How many people took applied math at some point? You, Dennis and Jack? Only. So that was a big part of your job, right? You have to make realistic windows and only look at the section of the graph. Because with these guys, just like Desmos, it just gives you the whole graph, right? And you have to decide what is proper for the situation. So you have to cut your graph off in the appropriate domain and range. So that's the same thing I want you to understand. Even though it doesn't look like a quadratic, at your grade 12 pre-cal, you should look at this and say, oh yeah, it's a negative quadratic. In the abstract sense, this is what the graph looks like, but we're only looking at this small portion of the graph because we're looking at only the positive numbers. Okay, so what type of function is it? Well, it's a quadratic function. So we're just doing a little bit of review of graph reading. What is the parachutist's height above the ground after 12 seconds? Okay. It's a little hard to read. Can anyone give me an approximate height after 12 seconds? What do you say, Rahel? Let's see. I'm saying 12 seconds is here, right? If I travel up, I think it's a little under 11,000 though, isn't it, Rahel? Because wouldn't it be, I don't know, about here? So let's see, what does each tick represent? Each tick is, okay, 1, 2, 3, 4, so this is 1,000. Each tick is 500, isn't it? 500 feet. So this is 8,509, I don't know, isn't it between 9 and like 925 or something? Someone help me out here. What do you think? Do you want to say like, this would be 900 feet, so it's a little over 900. I'm going to say 925, but someone correct me if they think I'm off. Because,
9,196.
is that what it is?
I mean,
Oh, because you plugged it in? Okay. That's a better idea. H at 12 equals, let's see, from the graph. Okay, so if I have my calculator, let's do the calculator, and Eduardo already did that for us. 11,500 minus 16 times 9196 using the equation. That's what, again, algebra is always way more precise than reading from a graph, right? When will the parachutist be 1,500 feet above the ground? Okay, if all we have now here, if you don't have graphing technology, we're just going to rely on the graph this time. This would be 1,000, this would be 1,500, right? So 25 seconds, would you say? About using the graph. Now, if we had graphing technology right away, we could do that easily. Approximately how long does it take the parachutist to reach the ground? Just using the graph. Approximately how long? Yeah, about 27 seconds to reach the ground. I'd agree with that. Well, that's good. Okay, so the big takeaways from here, I want you to notice that in applications, we're only going to be looking at part of the graph, right? Only the part that makes sense in the context of the situation. And then one more application. So same type of thing I wanted to bring to your attention. So here's what I was talking about a little while ago. A medical researcher establishes that a patient's reaction time to a dose of a particular drug is, and R is the reaction time. So the reaction time, R when the value is D, is equal to negative 3D cubed plus 3D squared. And D stands for the dose, and R represents the reaction time. D is the amount of the drug, and R is the reaction time. So here's my graph. This is a negative cubic, right? It says what type of polynomial, so it's a negative cubic. We can see from the equation, we can see from the graph that it's a negative cubic. Now, what are the leading coefficient and the constant of the function? All right, what would the leading coefficient be of this function? Leading coefficient is negative 3. What would the constant be in this? Yeah, 0, right? There is no constant listed, so it must be 0. What does this tell you about end behaviors and the y-intercept of the graph? Well, a negative leading coefficient means the graph ends down, I'll say, pointing down. And if the constant's 0, it means the y-intercept is 0.
You say negative 3 means the graph
And
ends down.
yeah, so when we read the graph left to right, the rightmost portion of the graph is ending down. That's what happens when we have a negative lead coefficient. Okay, so let's look at this graph. So we've got a negative cubic. What are the restrictions on the domain of this function? What is the domain of this function? The domain is all the x values, right? The domain is the amount of the drug. What are the restrictions on the domain of this graph? Yeah. Would it be? What part of the graph is really the only useful part of the graph for us? Yeah. Is this part of the graph useful? No. Why not? Negative amount of drug. You can't give someone negative amount of drug, right? What about this part of the graph? Is this part of the graph useful? Because this is time, right? For once the y-axis is time, we can't have negative time either. So that part of the graph is not useful. So the only part of the graph that's useful is, if we're talking about domain, is from 0 to 1, right? What are the restrictions on the domain? The domain is only from 0 to 1. And that was drug amount, right? From 0 milliliters to 1 milliliter of drug. Whatever that is. Okay, so this was a 1. Okay, so they're just saying estimate, we're just going to use our graph, the amount of drug required to achieve the maximum reaction time. Well, this is the maximum reaction time here, right? So if this is 1, the scale, it looks like 1 tick is 1/3 of a milliliter. So I don't, 2/3 of a milliliter? Or 0.67 of a milliliter of drug? Because it's 1, 2, and 1 whole milliliter. So 2/3 of a milliliter? I don't know. Again, this is just to establish the fact that not every part, we need the whole part of the graph, because the whole graph is, the function represents this whole graph, and we need this function to solve our problems, right? We need all the parts of this math equation to solve our problems. But when we actually graph it, the only part of the only amounts of D, right? The only amounts of the X value that will fit the equation are located in this little interval. And that's typically what happens in a real world application problem, right? We're only looking at little pieces. Okay. What I wouldn't mind you guys doing, just to get a sense of what the bigger picture is, how about you, if you have a phone on you with a smartphone and you want to use your phone, that's fine. But for the rest, come and grab a Chromebook, either from here or here. Those ones are plugged in, I think. Okay, we're just going to log on to Decimals. Now you have to, has everyone logged on to a computer here at the school? Because you have to have a your username and your password, right? Everyone know that? Okay, come grab a Chromebook or use your phone if you want. It's up to you. Chromebooks are a bit better because you have a bigger screen. We're just going to play around with these a little bit. Just, yeah, you just have to do the same. And I think just probably will be recharged. Yeah. Okay, so see if you can get logged on. It should just be however you normally log on to a computer. It's dying? Just grab another one then. And there's one more here. That should be nicely charged too. Are they? Oh, I'll use Decimals on the computer, but just in a search bar, just type in in Desmos. Just do this. And I think a lot of you had already used it before, right? So you're going to type in Desmos. And I'm going to do that here. And I'm just going to pick a couple questions to play around with. Yeah? Sorry? Did the librarian ever write it down for you? Okay, I'm going to log you into with my account. So you guys don't order anything on Amazon or anything. Everyone else logged on? Let me just try, and I'm going to pick out a question. I'm looking at, like, I wouldn't mind doing one of the ones we did in class today too on Desmos, and obviously you can see how great a graphing program, graphic technology is. And honestly speaking, if you were working in an industry, you would not be doing everything with pen and paper, right? You would be doing this with technology. But the reason we're studying things and pre-cal is intending you to get prepared for calculus, and in university, almost every calculus course is absolutely done with no calculator, right? Because you're learning the basics of calculus, and you can only really get into the basics of calculus using your brain and pen and pencil. Then as you get into your program, whatever you want that to be, that's when they start to introduce technology, right? Whether it's engineering or Asper School of Business. So what I thought we'd do is, there's a question on in the chapter test number 15. I told you to omit. That's one of the ones, and then I'll work backwards a little bit. But it said this is what it was. It was 8x cubed plus 4x squared minus 2x minus 1, okay? Now that was one that it talked about rational roots, because some of the roots are, now it's a positive cubic, right? So look how easy it is. While I'm typing it in, Desmos is already graphing it. Now I don't know exactly how it's working on the Chromebooks, because I've never used Desmos on the Chromebooks. But I've just used it on a graphing or my phone or the computer, but with the mouse you can zoom in and out quite easily, right? Okay, so what are the, how long did that take me to type it in? 15 seconds? And here are my answers, right? No number crunching, no long division, there it is. So, like in applied math, you can do this for all your tests in the exam, right? Of course so now you just figure out so here's one of my answers, right? One of my roots, negative 0.5, positive 0.5. Those are your answers, right? Done. But you can see why in a pre-cal class, they're not going to say solve all your questions using Desmos, because if you started off factoring polynomials just using a graphing program, would you really understand the parts of the polynomial or how they go together or where the answers came from? Right? Probably not. Without a graphing program, you're forced to really understand the parts or the sections, right? How about this one? This is another one from that you couldn't do yesterday. I'll write it on the board so you don't have to keep referring. I want you to solve using Desmos. Solve 5x cubed minus 11x squared minus 17x plus 15. Okay? Yeah. And if you need help, I'm just going to walk around, make sure everyone knows how to type things in. Do you want to know, okay? Okay, did you solve that one? By the way, if you ever wanted to graph another, all you'd have to do is, if you just enter, you can graph tons and tons of graphs at the same time, right? So I'm going to erase this one. And what do we have? 5x cubed minus 11x squared minus 17x plus 15. Okay, so here we go. Now, it's lots easier for me, like I said, because my mouse really helps me out a lot. Okay, I was saying to the others, I'd like to reduce my X scale easily. I'm just not sure how to do that. I think maybe if you go into settings, no. Tools? Yeah, tools, I guess. So you could, if you went into tools, you could, I'm going to delete, or I'm going to drop my X values down really low. I'm going to do negative 20. Let's see if that works. So that helps a bit. So it's under tools. You can play around with here. Okay. So what are the solutions? Negative 1.477, right? You can see why you never do this by hand. You couldn't do this with pen and paper. X equals negative 1.477. I'm thinking there's 3 answers for X, right? Because there's 3 X in X. It's a cubic.
The other one is
0.677 and 3. Okay? 0.6773. That's why I told you to admit it, right? You never do this one by hand, like with your synthetic division, right? So what I'm going to do now is, I got a couple questions for you to do. I don't have the answers written now. We're going to do one together, and then you're going to play around a little bit with these. And I'll give you the answers later today or in the blog tomorrow. So here you go. And throughout the textbook, there are a few questions, like I said, that came in previous assignments in the book that said use graphing technology. So you could go through and try and solve some of those ones as well. So we're just going to see how. Okay, so let's take a look. The first one again says, an antibacterial spray is tested on a bacterial culture. The population of bacteria is represented by P. T stands for the number of minutes after the spray is applied, and it's all modeled by the following polynomial function. They give you a big polynomial function. What is the population of the bacteria 3 minutes after the spray is applied? Okay. So, we could plug this into, we could definitely plug this into the calculator, right? And get your population answer just putting it at 3 in. But more importantly, I want you to just to get a feel for what the graph looks like, because you can't really do a great job of graphing, sketching graphs when the numbers are quite large. But and of course the x just stands in for any variable that they give you. So I have t cubed minus 2x squared plus 3x plus 800. All right, so here's my graph. Now you do have to play around with this, I suppose, a little bit, right, to figure out a good. Well, that doesn't. That one's hard to read, right? I have to really blow it up. Yikes. That's a really tight graph, isn't it? Okay. So here's your graph. I don't know if Desmos really helped us. Right? What part of the graph is applicable? It's only this part of the graph, right? Actually, if I just do this, can you see that's the only piece of the graph that's really helpful for us? I'm going to go to my tools and do 0 to, like 0 to 50. Let's try that. Okay, that helps me out a bit, right? I could actually go smaller. 0 to 10. Okay. Does that look more reasonable? Okay, once again, why did I cut my graph off like that? Yeah, it's the situation, right? So it's talking about population. It's a living organism. The bacteria is something alive. It's a population. T is time again. So the only quadrant we're interested in, this is a total quadrant 1 graph. Agreed? I don't know. How easy is Desmos to use for you guys with the Chromebooks? What kind of window did you guys get? Does yours look like mine? Could you play around, or is it really hard still? It's kind of hard, right? Yeah. All right. Okay, I just wanted to introduce it to you. You might not, like for some of these you don't necessarily have to use Desmos, but I want to just draw to your attention one other type of question. And then I'll leave you alone to work through these, and I'll give you the answers in a moment. Give me 1 sec. Maybe if you guys want to maybe go for a break now. How about going for a break and then come back, and I'll have one little question for you, and then you can just have the rest of the class to work through these word problems. So go for a break if you need to. Let's see your phone. I'll show you how I did the.
Looks weird. Like it's on the.
Oh, yours is
zero.
different.
Yeah.
-2
Is
x
it like
cubed minus
the
2x
right
squared.
setting? Like, is this like just the basic setting for the graph? Or
Just see this. Why does yours look so different though?
I was able to.
Oh, I
stretch it
know
out.
why. I know why. Look how high it is. Look how yours is going to 5. Yours is
Oh.
50,000.
I
See, I'm only at 1,000. That's why it looks. Doesn't it look like it's cutting through 0?
Yes, that's why. I was
Okay, so
confused.
let's go to the y-axis.
Well, like I could just stretch it with like.
Oh, okay. Do that.
I think you could do this. I think that's what I messed up on right there. So is it getting big? Oh, I have to like zoom in.
Yeah,
and
go
get
that
smaller.
way. Yeah, that's better. Keep going. Good, 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 good.
That's all. Okay, I see.
Keep going on the Y. Keep stretching the Y
Okay.
till you get to like 2,000 or 3,000. It's a great thing for homework though, right? To have to check your grids for homework.
I didn't get this question.
Okay. Yeah, this is one I wanted to do. Okay, are you okay with how I defined X?
No.
Okay. If I say that numbers are consecutive, they follow one another. But if I also say they're odd, that means they have to be 2 spaces apart. Because odd numbers are 2 spaces apart from each other, right?
Yeah.
So if I just if I call my first number a name X, for example, if the next number that I'm looking for is the next odd number, then my next number has to be defined as X plus 2, because it'll be 2 units away from X.
Yeah.
And then the third number would be 4 units away from X. Right? If my first odd number is 1, then 3 would be 2 units away, 5 would be 4 units away. If, like, let's say my first number is actually X, 5 is 2 units away, 7 is 4 units away. Okay, so those are my 3 numbers. And they have to multiply it to be negative 105. So this times this times this is negative 105, and then I just multiply through, combine like terms, put everything to one side so I could factor it as a polynomial. To do my long division, that's what I was doing.
Yeah, I get that.
Right? Yeah. It was just how to define them in the first place.
Yeah.
Okay. Maybe what I'll do is I'm going to do that. That's what I was going to do. Go back. Eileen, did you want to go to the library and get a new, or do you have your password and all that somewhere? You just. Is that at home? Because if you've never, you can go to the library and get all that info from the librarian. Tell her. It's up to you, because the librarian will give you your username and your password. Okay, you've got it. Okay, that's fine. Yeah. Yep.